Tell me about what you are presenting at NeurIPS.
So I'm actually here with my company, Inception. We build diffusion large language models, and we're the first company to produce production-ready DLLMs.
And can you tell me what a DLLM is?
Yeah, so traditional large language models like your ChatGPT, Claude, etc., are autoregressive generators. So that means that they predict one token, which is like a piece of a word at a time. Diffusion instead predicts multiple of those in a single. You can think of it as like filling in parts of a sentence on each step that previously you would only get like a little piece of a word. And that makes them a lot faster. And there's also a lot of philosophical debate about whether this is like more representative of the way that humans think and decode language. Yeah.
Wait, tell me about the philosophical debate. That sounds fascinating.
You know, there's the question of what is useful to model left to right. Like English language, sure, but Arabic, no. What about images? No, it doesn't make sense to generate images left to right. There's a lot of things, DNA sequences. That's why diffusion is also like a popular application of DLLMs is also in the biology space. Basically, it's challenging the orthodoxy of left to right generation that we've had in the language model space. And, you know, in the limit, we're just trying to understand how does language fit together. And that's not necessarily a directional thing.
Got it. And so far, has image generation been the main use of diffusion models, or are there other areas that we are already seeing them being pretty widespread?
Yeah, so definitely in the past, we've mostly been doing diffusion in the image space. All of the kind of popular image and video generation technologies use diffusion, but now there is a pickup of interest in discrete diffusion because of the benefits for latency, especially.
That's exciting. And how did you in particular get into this space?
It was definitely somewhat random. I was doing research, so our CEO is Professor Stefano Ramon, and he was one of the founders of discrete diffusion technology in the SED paper. I was actually working on more traditional, autoregressive foundation models before this, but when I kind of came across diffusion, I thought this is a really interesting technical bet, especially in a time where the industry more broadly is kind of maybe taking a incremental gain approach of we know this one thing works, so let's just keep pushing it. Diffusion is kind of very perpendicular to what most people are doing in the industry, and so I think it's really fun to be the underdog in that way.
Yeah. Does it feel lonely at all, or do you think that people are starting to feel like there are other approaches worth exploring?
I think it's good if it's lonely, because that means no one else has been able to make it work. We know that Gemini is also working on diffusion, and ByteDance has tried as well, so yeah.
And what are their motives for doing it?
I think similar. There's, again, autoregression is just the paradigm that we've started with in the transformer language modeling space, but there's nothing to say that that's the ideal, and again, it's a lot faster.
Yeah. I wonder, are we already seeing that latency is a big advantage when it comes to building consumer applications and things like that? Or tell me why latency in language models is really important.
Yeah, it depends. I think if you're using a deep research type of application, of course, you might be happy to just say, okay, just figure this thing out for me, and I don't care if you take a day or a week to do it. But there are lots of things where you want really quick feedback loops. Even I would say this conversation, for example, is benefited by the rate of feedback, is that you're constantly listening to and responding to what I'm saying. There's not a delay where I'm waiting for your first word after I finish
voice
speaking.
Applications.
Yeah, so voice applications, also code, when you just want lightweight, when you're typing and you just want it to fill out the rest as soon as possible. And some people even say that they just want that drafting process to be built in of I don't need it to be perfect on the first try, I just need it to be collaborating with me in real time. Yeah.
Yeah, I've heard some people say oh, the problem is I don't want to be chatting, I just want AI to feel like a natural extension of my arm or my body. And maybe a faster model would help with that.
Yeah, I totally think so.
That's super interesting. What was the thing I was going to say? Oh no. So are you excited for, what other research are you excited to learn about here at NeurIPS?
I also have a bit of a background in robotics, so I'm really interested to see the vision language action stuff that's going on. I saw there's a workshop on this. More broadly, I think just walking around a conference, you get a sense of what are the clusters of things that are really hot. And obviously recently, with work, I've been more siloed into the diffusion space. So yeah, just like the energy and see what's up.
Yeah. what do you think of the whole humanoid robot craze that's going on right now?
Oh my God. I think this stuff is going viral on social media. Have you seen like the household robots in
course,
China and
yeah.
stuff? I think I'm not super convinced by the applications that people have been demonstrating for household robotics and humanoid robots. For example, I know there's a company which is a great company with very, very smart people, but they are like solely working on making robots good at folding shirts. And I asked, is this really the most useful application of like really advanced technology, especially because when you're training for that objective, you're not just like sitting in a room using your GPUs to do that. You're actually sending this command to like hundreds of people in India who are then like folding these shirts with like a GoPro on their head to create your training data. And I also don't know if, that's the best use of human resources more generally, like, thousands of human hours. Obviously, I think there's many reasons why they choose this problem. It's tractable, it's not dangerous. So if a robot messes up folding a shirt, there's no harm done, nothing is broken, nobody's hurt. But yeah, I do think that maybe the problem selection could be a bit more inspiring in robotics.
Do you have ideas?
I'm sure there's a lot of work on this already. Well, actually, to be honest, even in the household domain, I think cooking is really fun. If a robot could cook you a good meal, that or even just scrambled eggs, I think that would be pretty great, and I would feel more convinced that this is like something that is improving human life.
Do you think that the reason that these robotics companies are focusing so much on folding shirts is because they actually want to automate the process of folding shirts, or because they do think that whatever that skill is of being able to fold a silk shirt versus a cotton shirt or whatever is going to generalize then to other sorts of tasks?
Yeah, it's a really good question. I think that my bias for understanding how a lot of transformer-based models are seeing such powerful gains right now is that it is still mostly driven by data. So, and we know that in practice, like, physical intelligence is buying robotics data from like every other robotics company, that they're spending like a ton of money just like paying contractors to execute the actions that they want to imitate. So I do think that the generalization capabilities are in the air. Like, it's hard to it wouldn't be my instinct to believe that folding shirts would generalize to other useful activities.
Yeah, that's really interesting, because I've also been curious as to why narrow in on such a particular skill. Like, is it that folding shirts would be the equivalent of early, RL agents playing video games, but somehow even the video games feel more impressive than folding a shirt.
Folding a shirt is hard. It's definitely a tough technical task.
Yeah.
But yeah, I guess.
But like, would it, part of the benefit of the video games is like you can stage these like big competition matches, and you can raise a lot of money and recruit a lot of people. I'm wondering, like, does an AI researcher go like, maybe they do, like, oh shit, that robot can fold a shirt, I'm definitely going to join that lab.
It's a great question. I think that among robotics researchers.
Okay. That was amazing insight. Thank you so much. What are you most looking forward to in terms of the applications of AI in the world?
I think education. That's already here, and I think we're yet to shape it in the best way to make it maximally useful, especially for kids, because I think right now, like, ChatGPT is just a kind of cheat code, but it could be so much more than that. And I think this idea of like everyone having a personal mentor, everyone having at least one like entity in the world that cares only about like deeply cares about their life is actually really valuable, and it's something that's like probably underrated. I think maybe a lot of discourse about LLMs being bad for education or like emotional development and stuff kind of presume that the baseline is that everyone has a teacher that cares about them, or a teacher that can give them the time of day, or everyone has a parent who cares about them and can give them the time of day. And that's not true in practice. So I do think it's like very tricky terrain, but if we could do it right, I think that would be like very revolutionary.
That's an awesome vision to end on. Thanks so much for being here, Joyce.
Thank you. Yeah, this was really fun.